Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right, hi everybody. Welcome to Anita Sarma's talk. I'm Andy Bagel, a researcher in the Vibe group, and Anita is a friend of mine who has had a nice long history in software engineering. She did a PhD at UC Irvine with Andre Vanderhoek. She's the author of the famous Palantir conflict avoidance tool, which when I saw it, I was like, damn it, why did she invent that before I did? Because that was a really awesome idea. After she finished her PhD dealing with coordination issues for software developers, she went off to a postdoc at Carnegie Mellon, worked with Jim Herbsleb, Marcelo Cataldo, a bunch of people there doing kind of neat things in socio-technical congruence about trying to match up software teams and the work that they do together and try to keep that in sync. And now she is a professor for the last 4 years at University of Nebraska in Lincoln, Nebraska. Which is where my father-in-law works, so that's kind of exciting too. She has been working on a lot of things, continuing in conflict avoidance for software engineers and trying to help generally software engineers improve their coordination. And she's going to be giving a talk today about distributed software development and how to deal with coordination there. So I give you Anita.
Thank you. So that was a nice introduction, thank you. So right now I'm at UNL, and our research group is called E² Lab, Empirically Based Software Quality Research. So we don't just build tools, we try to make sure that the tools are useful. And that's one of the reasons why I'm here. We have had this amazing idea, built a new tool, and then after talking with Andy, started realizing what is the context in which it's actually going to be used. So one of the things I'm trying to do here is talk to developers to kind of see the kind of problems I'm trying to solve exist, and if not, what kind of problems they actually have. Just a little brief introduction about what I do. I have 3 strands of research. So first of them is empirically based to understand what's really happening in these communities that are actually doing some kind of software development or any programming related tasks. So in understanding online communities, because they are easy to get the information from, open source development or Q&A, programming-based Q&A sites like Stack Overflow. So one of the questions in that area I'm interested in knowing is what motivates them to contribute. And now we don't even have a single project anymore. Like if you're doing your work, you realize you need some other project. You need people's expertise from some other project maybe. So it's almost like an ecosystem. There's no monolithic project anymore, like no island, right? We have an ecosystem. People have not yet looked into what happens in ecosystem. Can I learn the social norms and technical knowledge from one project and transfer them to another project? So that's this little chunk of my work is looking at these online communities, understanding how people migrate from one project to another. Are there transferable knowledge? Are there specialized roles? Another part is end user software engineering. A lot of you guys use Excel, and there's a whole bunch of people out there who do some kind of programming. Not because that's their job, but that's because they need to do that to get their work done, right? So Excel, web mashups. So over here, I'm interested in understanding what kind of software principles and techniques we can actually get from software development and help this class of users. Looking at how people do debugging in end-user software, people just don't write code from scratch. They pick some example from one place, put another example from another place, try to glue them together and see if it works. But when that happens, you don't know the kind of examples that you picked, and when you put them together, where's the problem? In the glue code, in the first code you got, in the second code you got, you have to change it a little bit, but you don't know what's really happening. So can we help these end users debug and looking at how they even go out, look for examples, how they are trying to look for problems, looking at information foraging theory to look at the foraging behavior. The other strand, the one that I had started with in my PhD project, still continuing, which is how can we support coordination in teams. And in these strands, one of the things that I already talked about, we want to look at the state of practice that's existing, try to understand the theories behind what's happening. Based on those theories and insights, build tools, and then evaluate them. And that kind of encompasses my research directions. Today, I'm going to talk about mainly supporting coordination in teams. All right. So starting with software development. This is a little nice piece of jigsaw puzzle that's out there, and that's really what software development is. We have these different pieces of code that we have built by different people. There's no more one person building all the project and all the code, right? We have to divide labor, we'll build things together in. And what usually happens is, this little spaces you have is almost like workspaces. You take from the main repository or wherever the main archive code is, you take it out, you work on it. Once you are done, you try to put it back into the system, and hopefully all these interfaces line up. While you're making changes, nobody else has changed any of these other interfaces, right? So you're hoping as I work and I put things back in, it will be amazing piece of technology and it'll work. What happens in real life? Here is the dependency packages in the Perl language. It's a pretty simple language, right? And the pictures from Visual Complexity. But if you see this picture over here, the blue stuff is package. And what you're really seeing is a whole bunch of spaghetti code. There's calls from one package to another package, calls from a file in a package to another file in another package. What that leads to is then social dependencies among people. Because I'm dependent on, say, Chris for his file, I get to have to coordinate with him, find out what he's changing. If he's mucking around with his code, that might impact me. So if you look at the social dependencies among these people, this is what you get. And to make matters worse, these dependencies are not static. They are changing over time because everybody is evolving code. So here's the same Perl language. In this case, you have the vertical lines, which means a particular version or revision. And between revisions, you can see how much the code has changed, right? So some versions don't have as much changes, just a little bit. Some have a lot of change. It might be because of the new release or it was an important part of the project, right? So the take home over here is there are dependencies. People depend on each other, and it's a moving target. Things continuously change. There's been a whole set of studies done to understand how do developers work in this kind of settings, and more specifically looking at what kind of questions do developers have to ask. Some of them is like, who do I go to for help? I just started on the project. I need to work on this work. I need to work on this piece of code. Who has the expertise? Who can help me out? This is especially true if you start a new project, right? You have to understand who's the expertise. Who should be assigned to this task? Who has the right expertise who can get this done in the shortest amount of time? Sometimes bugs keep getting reassigned because you assign it to someone, they don't have the expertise, then they assign it to someone else. So we call this hard potato bugs. They get getting tossed from one person to another person. Which tasks need to be completed before the others? There is dependency. If I am depending on some release or on some code to be done before I can get my work done, I'm getting blocked on this other person finishing their work, right? So how do we manage or interleave these tasks? Other two questions is, which other artifacts are affected by my change? I am here making changes to my code. Who else might be affected because of that? On the other side, as I'm working on this really important topic. Who else is working in the space in my team that can affect my work, right? So these are the questions you have to ask, because as I'm working in my space, I need to know what's the impact of other people's work and what's the impact of my work on others. So if you look at a bunch of the questions, is about the impact, and coordination can lead to, or breakdown in coordination can lead to two kinds of conflict, I say. First is a direct conflict, which is I'm working on this piece of code, someone else works on the same piece of code, and when we're ready to synchronize, we cannot do that. In the case of where we have configuration management systems like Subversion or Git, usually what this translates to is a merge conflict. You have changed the file, Andy goes in first, he is happy because he gets to check in, I go to check in second, and boom, I have a merge conflict. And then I have to kind of see how to merge them together. It might be that they're the same file, but the changes are in different spaces, so I can merge them pretty easily. But sometimes it could be that there is some dependency that goes from one block to the other block. So what happens then? I stick it in, we don't build, or we run test, and then something still doesn't work. Or another case where things look fine, I build fine, everything is fine, my unit tests go fine, I stick it into the configuration management system because all the files are fine, but then something fails, build or test. And that might be because something I was dependent on, an API or some behavior got changed on the side, and when we actually ran the build test, that's when things failed. So these are undesirable consequences, and literature studies in different kinds of projects, some pretty large communication projects, some were telecom projects, some were at NASA, some were smaller projects. A lot of studies has been done that shows this is a problem that keeps happening. Work is frequently restructured because what you would want is all these little pieces to work, but these little pieces should be given to separate teams with good APIs. But as you keep working, things get changed, right? So you have to restructure work to bring back the modularity. Parallel work does tend to lower the quality of the code, and that's because you will have merge conflicts, and sometimes when even you automatically merge it, there might still be some problems. Developers recognize the significance of conflicts. Nobody would like to do conflict resolution, even if it is merge. Merges are hard because going back to the old cases of SVN, when you actually do an update and merge, you get a lot of squiggly lines, me, them, me, them. You have to go through all of them and try to fix it, right? So people have seen that people try to race. So they would say, this is very old work, like from 95 from Becky Grinter. And what she saw was people used the CM system logs as almost like coordination time. Like, OK, Tom checked it out 1 day back. The release is coming up in 1 week. So he would be at this stage. So I better hurry up because I want to check in first. I don't want to do resolution. People also sometimes use another practice called partial commits. So even though my thing is not completely done, it's not tested yet, I want to put part of my code in because at least then that part of the code will be saved from me having to do resolution, right? And these kind of informal practices kind of go against the basic software engineering principles we have that you should have tested code that goes into the system. Another thing is informal communications take place. This was from a study an aerospace company, and what they did, they had really long check-in cycles, that is almost 2 weeks long. So people would check out and keep working on their code. In 2 weeks' time, they'll be ready to finish and put it back in the system. That is a long time when things can change. So what they would do, they'll send an email out, hey, I'm ready to check this piece of code. This piece of code has dependencies on these other artifacts. Is there someone out there who will be affected? Speak now or forever hold your peace kind of stuff. And then they'll have all this email communication back and forth outside of the CM system. Once they knew what was happening, who was going to be affected, and how changes will actually be integrated, then they will go ahead and put it in the system. And this is something I found when we were doing it in a class project with my tool Workspace Awareness. We were like, nobody had any conflicts. It was amazing. All this 4 people project, nobody had a conflict. And then I got the email logs, and there was a whole bunch of actual informal communication and coordination going on outside of the configuration management system. And they only had, in this case, the student had only one person who could check it in. So he was the manager. He would get all the code, make sure everything worked fine before checking it in. Resolution is time consuming. A recent study by Brun et al. And my work has shown in open source project that resolution time takes hours to days to take place. One thing I have an intuition about and has been a little bit talked about in literature is everybody knows about this merge conflicts, and that is a coordination problem. But many people recognize that indirect conflicts like test failures or build failures are also actually caused by coordination problems. They think that's the regular day life. You have nightly builds and you have all these processes set up to overcome this problem. Nobody thinks that if we could actually coordinate better, if we can understand these dependencies, maybe this whole class of problems would not be even here. That's what I want to poke more in. In my study, which we looked at 4 projects, that was also the 4 projects that Yuri Brun and his colleagues had looked at. So we wanted to see, OK, do conflicts occur? How big is the problem, right? This before I go over trying to solve this. So if you look at these projects, we have, all these projects were in Git. So we looked at the number of merges there were. And the way we looked at the Git tree structure was if there was a merge, that is 2 branches actually merged together, we would run, if it was a safe merge, it was a clean merge, then we would run a build script. And these projects had the build and test scripts. If the build passed, then we would run tests on them. So we maybe will make sure at the range how good the quality of the code was. And when we look at this, you see the total number of conflicts range from 40% to 54%. That's quite a few number of merges that had some sort of problem, right? Further looking at breaking these conflicts into merge, build, or test, we see that it ranges very differently for different projects. You have some had 14%, Perl had only 18%. Then we also wanted to look at the time it takes to resolve these problems. And this was surprising to me because I thought merges would be the easiest to solve. In the case of Perl, it took an average 23 days and a median of 10 days to resolve this merge conflict. Caveat, these are open source projects. It does not mean when there was a problem that they actually eventually went and resolve it then and there. This is how long the merge or the problem existed. Going through, it seems like build failures is the easiest for Perl to manage. Test and merges are difficult. And different projects show different profiles. But takeaway home message is you have merge conflicts between 8 to 19% of all the merges would have problems. Build of the clean merges range from 2 to 15%. If you look at the test conflicts, up to 35%. So there's a lot of problems out there.
So merge and build conflicts and test conflicts are common among teams where multiple people are working together.
Yes.
And increasingly, there's lots of pieces of software that are individual developers or small numbers, something like apps, for instance. How do you see, certainly there are socio-technical issues there, but they're entirely different than these type of conflicts, I think. So how do you see sort of in general, like software development, do you see these types of conflicts growing?
It depends on the process, right? So if you're doing agile, it's less time that people have to make changes. But if you are talking about that individual pieces are being developed by individual people, like in a branch?
No, I don't even mean that. I mean some 16-year-old is developing a game for iOS, and he doesn't have, he's the only person on the project, right? So he doesn't have these type of conflicts.
So then these exactly merge conflict and build failures would not exist. What he would have problems is when he tries to have the game work on a particular operating system, that's when things would change. So this is really, if he had worked off from version 1 and now it's version 2, forward compatibility versus backward compatibility, and then he'll have to fix it. So I think if this is based on a team setting, these kind of problems. If it is individual problems, it is the dependency that you have with one API, multiple APIs, and keeping up to date about which API you have built on and how far it has moved. So that's where I think it'll go.
Right. So I guess I'm asking you to speculate about the API API conflicts versus this type of conflicts in the future. What are we going to see more of?
I think these kind of projects still going to stay. If you have individual people building stuff, I think the APIs will not be as big a problem because there should be backward compatible in the APIs. And they are slower moving than the semi-structured APIs within a team. So yes, they will stay, but it'll be not as bad as these. And the way you resolve it will be different because you really do not have any control over what this other API is moving towards and where it's going because you are kind of a consumer, you are a client for that API. So unlike until you have like a Facebook kind of application which is very big, you probably will not be able to have any impact on the API development or how fast they're moving. Yes, sir? All right. So as part of my work, what I want to do is, as I said, the reason these problems occur is because there's some kind of dependencies. And I want to say, can individuals be able to visualize what these dependencies are, understand who is interdependent on their own work, and then can we help them coordinate the tasks? So first I'll start with visualizing the software dependencies. So built a tool called Tesseract, which is a multifaceted way of exploring your own project. What it does, it has an environment that correlates and understands relationships across these different entities. In any particular software development, you have these different silos in which your data exists. You have the code versioning system where all your code exists, the bug versioning system where the issues and bugs are there, then you have email communication that's going on the side. But anytime you want to look into this data, you have to go into one database, look into it, then look at the other part, and try to decipher the links or relationships between them. So what this tool tries to do is kind of says, can we explicitly state how these relationships are and how they are over time? So the tool, this is in open source data, Rhythmbox in GNOME. So what this does, it has 4 panes. On the top pane, you can choose a particular project, and for that project, it then shows the activity level of that project. On the top part over here, you see the blue lines, and those are the code commits that happened over the course of time. And on the bottom is the green lines, which is communication, how much communication happened. And in this case, in GNOME, we had the email exchange from the mailing list. We had any kind of comments that were taking place in the bug database, Bug Tracker and Bugzilla. And anytime there were any patches, so we're assuming that if I submitted a patch to Andy, Andy looked at it, he probably knows what I was trying to communicate. And if Chris comments on that particular bug, he probably read what I had written. So that kind of shows a communication. In this case, all 3 of us are communicating with each other. On the left pane, it shows the file network graph, and it shows how files are connected with each other. Since this is open source data, what we used is if two files had been committed together, we call it logical commit or co-committed, there must be some kind of logical dependencies between these files because of which they were committed together. On the right-hand side here, we show the social network or the people network who's communicating with whom. And the bottom part is the bug database or the number of bugs that were open for this period of time that we have. If I look more into this email communication or the communication network, what we have tried to understand is congruence. And congruence really means what's the fit between the people who had to communicate and who are actually communicating, right? So in this case, if Chris, Gina, Andy are working on some project together, there is some dependencies, right? So what we are saying, if they have checked in some files together, there is dependency between the files, there's dependency between these people. So we say there is a need to speak. And if you look at the green network here, so that's the gray one here. The green network says these are the people who are actually communicating with each other. Then we do a map between these two networks to see if they had a need for communicating, and that's green. If they had a need to communicate, but they were not communicating, that's red. And there is this gray line, which means we didn't see any technical need for them to communicate, but they are still communicating for some reason, right? So we call this the congruence. And the thickness of the line shows how many times they had communicated with each other. It's just edge weight. So going back to the picture, so I had that big cluster of files, and it says that's too many for me to understand, so let me filter it out. So over here, I've filtered out that only show me edges that have been committed 5 or more times. Then I get this network. And I see, okay, this particular node over here, shell.c, is kind of central. So I want to know who has been working on that. So if I click on it, in this communication network, it highlights the people who had ever worked on this file. And then I can see, oh, these people are actually communicating with each other. So maybe whatever changes had been done, they actually knew about.
What's the significance of the edge lengths in the file graph?
This is just a force-directed layout. So if you're farther, it just tries to put them away. So if they have been connected multiple times, they'll be closer. It's just a layout picture. Okay. So if they are farther away, it's just trying to keep the graphs as far as possible. Okay. So in here, you have them closer because there are multiple connections going on. All right. So other thing I could be interested in knowing is, all right, here is my bug list. If I click on a particular bug, this tool tells me, okay, the 2 people who had worked on as part of this bug are these 2 people, and for this particular bug, these files had been changed. So what Tesseract does is it allows you to go from one perspective of your project, say my bug reports, to kind of my developer history, to kind of my project history. So it allows you to explore how things are connected and give you more idea of what those relationships are and what they might mean. When we looked at user studies as well as just interviewing with GNOME developers, what we found, especially for GNOME, was people who were seasoned developers who had been doing this project for 5 or 6 years. They said, I know this network. I am perfectly aware of which files changed with what. I know who is working on what. Then we asked, so how do you know that? And this particular person would spend morning every day at least 3 to 4 hours going through the entire mailing list, kind of seeing what's the status of the project. He was that into the project, right? But he did say it'll be really useful for onboarding or finding expertise finding for people who do not care about the project that much. So his was if you really care about this project, if you're an open source person, you should know this. You should have this mental model in your head. If you're not that serious or if you're new, this tool would be really helpful. A couple of them were managers, and the thing that they picked on was I love when I see a red line, right? Because I know these 2 people should talk, but they are not talking, so I should be able to facilitate them. Another thing that came out was what we have in this data is only things that are archived. So even if I am not talking with someone over email and maybe over a bug tracker, it might be I'm sitting right next to the person and I talk to them all the time. So one of the tool features they wanted to say was yes, it's a red line, but I want to click it into green because I know I have communicated with that person. Or as a manager, I know these 2 people talk to each other during the meeting. Another thing that was interesting was we had brokers in the communication network, not in this picture, but we would see that A and B had a red line between them, but there was this other person, C, that they communicated with. Right? So it would say even though they're not talking directly to each other, there is a manager, there is some facilitator through which information is passing from one node to another node. Of course, the success of this project depends really on the existence of link. Oftentimes, you don't find that in open source data at least. So if you have the commits that have happened, the files that have changed, how do you link that to the bugs? Or how do you link that to any of the patches that have happened? So that depends on the link. And Chris Word over here had this tool that was allowed to actually decipher the links or add links to the commit and the bugs. So that will be really useful in a tool like this. So going on to the next set of tools, or two tools I'll talk about, is basically how to have coordination in helping with distributed development. So as I said earlier, we have this complicated, interrelated piece of code that we need to work on. We all work on in our own private workspaces. So the idea of workspace awareness was, can we monitor these private workspaces as people are going about their daily, everyday life? Can we know what files they're changing? What's the dependencies that they're changing to identify these potential conflicts, which will be the merge conflicts and the build conflicts that we talked about, which comes from dependency violations. And can we notify developers about this as things are happening, as people are still making changes? So instead of waiting till they have made their changes and committing it, can we move forward in time and say, as you're making changes, hey, this might be a problem and you want to talk to them? And that was the Palantir tool, which was my PhD project that Andy was talking about. So what we did was we wanted to make it really lightweight, because the more stuff you have in your development editor, it distracts you, it interrupts you. So what we tried to do was we just took over the package explorer view in Eclipse and made this really small little icons, right? So if you look at the blue icon over here, what we said was, you are working on this particular file, and someone else right now is also working on this particular file. So there was an option where you could have this on for all the files you had in a workspace, or you could have this view only for the files that you're dirty. That means you have changed it since you have checked out. And what we did was, just saying someone else is doing it, we also wanted to say, what is the severity? How big is the change that you'll have to deal with? And we did as the percentage of lines of code that have changed over the entire lines of code for the file. And the other was, we want to show them how this information could be percolated up the directory structure. Because it's often possible in a large project, you have multiple projects or packages that is collapsed. So we wanted to say, even while you're in the top view, if anything in any of the underlying packages or directories had changed. And for that, what we did was a very simple directory severity calculation, which we said, how many artifacts does this package or project have? Out of that, how many have been touched by somebody else? And just aggregate that and put that in the directory, and we keep going that upwards, right? So if your directory had two files, one was changed, so the percentage change for the directory will be 50%. If that belonged to another directory, which was two other directories, it will become 25%. Right? So it just keeps going up and getting decays a little bit. The other thing which we wanted to do was, merge conflicts are still easier to identify. Can we, in some case, find these build failures or these other indirect conflicts that are more difficult to find? So here we have this red little icons, and we wanted to say is, what's happening here? There is the changes in address with whatever is the amount of severity there, but changes over that is causing some kind of impact into your system. So that's what the I for impact leading out. And here you're working on credit card because you have this little arrow here which shows you're working on credit card, and the impact is coming to yours. So what we did was we did cross workspace impact analysis. It was very simple analysis, very rough analysis at this point. So for each workspace, we made a lookup table saying from call graph which other files and which other methods you're dependent on this particular file. And if in a remote workspace, if some method or some file was changed, we would get that notification. We'll just do a simple lookup. If you're using this method has been changed, we'll say there might be an impact. And this is right now at the signature level. So if anything actual behavioral changes, we would not have found out. If anything the signature changed, we would have found out. And we gave more information on this little view. And this was my attempts at drawing bombs. So a red bomb would mean that someone has changed a method that we're depending on. In this case, someone has deleted this particular method, getName. It's impacted by Ellen on Pete's work. And it says the red means that changes have been committed. So this is definitely going to be a problem. A yellow bomb meant something is happening in the workspace. So this might be a problem, but we don't know. They might revert this change back. And then green was if you have changed anything in your own code and you wanted to find out what else will impact in your particular project. But another interesting thing was this exclamation point. As I said, what we had done was a very simple call graph signature level analysis at this point. But what we wanted to say was, hey, in this particular research, you were depending on payment. Your credit card was dependent payment, and something has been added, something new. For example, an init method has been added. So the system was not smart enough to know, like, you were depending on payment, or a lot of the initialization code had been moved to this other method, so the behavior had changed. We said that's a lot of complicated analysis. The user usually has a lot better understanding of the domain knowledge. It has a lot better understanding of what the systems are, what people are doing. So we wanted to say by exclamation point, like, a new method has been added. What's the details of this new method? So as a user, if I know payment initialization is important to me, I will go and check what's happened or talk to Ellen to see what she's doing. So we tried to offload some of the more complicated computation part to the developers because they would know a better idea. So when we looked at the results, we saw conflicts were pretty good in being detected as they emerged, as long as they were at the syntactic level. We found developers undertake action upon noticing a potential conflict. And in our user study, we found a whole spectrum of people, right? So some people were, as soon as a little bit of a conflict information got in, they had to go look what it was. And there was one particular user who could not have anything that is, conflicting. So they had to go and like find out what it was, start an email communication or IM communication to see why it was. And then the other end of the spectrum were people who would just open the editor really wide, and they would not care about what's happening in the package explorer view. So all that details were lost. So only time that these group of people would look at the package explorer view or look at the conflict was when they were starting a new task, or when they were looking at another file, because a particular task might have multiple files, so they had to go open the package explorer view, or when they were taking breaks. One of the tasks in the user study was they had to write comments. People always wrote comments after the fact, so they would code everything up, and then they would open the package explorer view, take a break, look around, then write comments, look around, write comments, right? They didn't like writing comments, at least the students we had. So those were the times where people looked at the conflict icons. Fewer conflicts grew out of hand. This was, I don't have details about the experiment setting, but this was using a Confederate study. So we had one person come in, and we told them they're working in a group. The other two people could only be contacted through IM. But these were our Confederates, so they are our research helpers. And we had like every 15 minutes into a particular task that would be conflicting, we would see the conflict, and it was automatically checked in. So we saw some people trying to race. They would have this blue icon come in and said, oh, I need to go fix it before this other person actually checks it in. So they tried doing that, racing to finish it, then they realized it's already committed. So they were really, once they faced a conflict and they had to resolve it, they were really particular in making sure this other group of people who wanted to have no conflicts, as soon as an icon came in, they would contact this person and say, hey, I'm working on this task. These are the files I'm changing. What are you working on? How much time will you take to work on? So they were trying to synchronize and manage through the IM. So the resulting code was higher quality in the terms that fewer conflicts were left in the code base. And this was based on because we had seeded 4 conflicts in an 8-task experiment. There was a penalty because a lot of people were communicating over IM, and it takes time to communicate. So the control group people were faster than the experimental group, but they had more conflicts left in the code base. Once we said, OK, now experiment is done, here is all the conflicts or dependency problems there could have been. One of the faults in the experiment was, which I didn't realize at that point, we did not make the control group resolve all the build failures. It should have taken time. We didn't do that. Anyway, so that was fun. And there are a lot of other workspace awareness tools that have come after Palantir, done better jobs in UI and better jobs in the kind of analysis is being done. This is FastDash, which was from Microsoft, so Mary's group. And what they did was, like, here are all the files and all the people that are being worked on this in an agile setting. So they would say, which particular file, what's the status of the file. If a file is being worked on by 2 people, they show the names of the people there, and like, this is a problem space, you might want to look into that. This was by Yuri and his group, and what this has done, this is based on Git, and they look at, there is, Git works in all kinds of branches, right? Everybody has their own branch, and sometimes people do local commits, smaller commits, before they actually push the changes back into the master repository. So they had a shadow repository. They pulled in all the local commits into the repository, and they would be able to say, like, when there is a possibility that there would be a problem, a build failure or test failure, by actually running the build and test scripts on this master shadow branch. All right. So few of the limitations of Palantir and this other workspace awareness tools, or the way the approach works, is conflicts are only identified after they occur, right? So as I'm making changes, as I'm doing stuff, these monitoring spaces tell me, here is a file that is going to have a merge conflict, or here's a dependency that has been violated. And the more changes that have happened, the more time it will take to resolve. They are usually doing coarse grained impact analysis at this point. Because of these notifications coming in, there is the case of information overload and interruption that we saw from the Palantir study. And the opportunities for improving or extending these kind of analysis to a larger unit, like tasks or like scenarios and features that Microsoft uses, the problem is because all the analysis is done at the file or the directory level, so bringing it up to a higher level, like logical units like tasks, is kind of difficult from this setting. So what I wanted to do next was, can we go even more forward in time? Can we be proactive? Can we find these dependency problems, or find when changes are going to have any issues before people have even started doing their changes? Can we look at the tasks that they are going to work and figure out the dependencies at that point? So then we can also give them the solutions at the task level. And one of the things I wanted to look at was, would this avoid individualistic solutions, right? So in Palantir, when we had these blue icons or these red icons, people would want to go race in or do partial commits or talk to the other person and say, like, I want to put my code in, right? So it was a lot of individualistic setting. Can we look at it so that avoid the race conditions and this kind of individual strategies to see what is good for the entire team? Maybe it is OK for Chris and Andy to have some conflicts here because they are working on a code that doesn't need to go for this release. But maybe Gina and Tom should not be affected, right? So there might be, based on the team policies, different strategies that this could work. So we built Cassandra. So Palantir was the crystal ball from Lord of the Rings, so you will know what's happened in the 7 kingdoms. So you want to say, can we go to Cassandra, right? Can we predict, even before tasks have been started on, what are the future problems that could occur, right? So that's the Greek mythology, Cassandra. So we can minimize the conflicts that can arise from the individuals working in their workspaces. So this is the approach for Cassandra. So first, we are assuming a workflow where this is more akin to the workflow that might happen in open source. So I come in the morning, I say, OK, these are the bugs that I have in my inbox by pulling it from Bugzilla or something. I might want to order the task based on my preferences or any kind of priority that we have. After that, what needs to be done is kind of identify the files that's going to be changed for the particular task. And once we have the files that's going to be changed, what are the dependent files, or what's the files that can be impacted? And then we have to analyze this task to understand the dependencies so that we can understand the conflicts. And then we formalize those constraints into hard constraints or soft constraints, which I'll talk about in a few minutes, and then we evaluate them to find which tasks can be independently created. And we use Microsoft Z3 actually to do the constraint evaluation here. So let me give you an example of a constraint example. So here we have, say, shape.java. We have 3 other classes that are inheriting from shape. If we have a scenario where we have Alice, who has 3 tasks, TA1, A2, A3, Bob with TB1, B2, and B3. In task 1, Alice is working on rectangle and shape, and task in B1, Bob is working on rectangle and square. If you look at the example of the dependencies, right? So if Alice and Bob were to do their first task, they're going to be one merge conflict because they're working on the same class here, rectangle. They're modifying it. There might also be indirect conflict because whatever changes Alice might be making to shape might affect square or triangle that Bob needs to work on. And there might be some order like of task precedence, like canvas needs to be built before panel can be inherited from canvas and being built, right? So there is some precedence ordering that is also necessary in tasks. So what we do that, we convert that into hard constraints. That is, TA2 has to be done before A3. There's no other way around. And then the rest are soft constraints. So TA1 and TB1 can be done in parallel, but there will be some consequences with that. So looking at how do we get the constraints from the FE and the FD set. So what we are using is either we could use some kind of data mining if it's a bug feature or bug request that needs to be done. We can look back in time to find out what other bugs are similar, what other files might have been changed for that bug, right? So we have a seed set of files that will be changed for that particular bug. And the user can definitely refine it by adding more files or removing more files, going back to like how Mylin does its context. So usually you will have a task. You can say, I'm going to change these files. I'm going to look into this file. So we can have some developer input for refining. And then we can do a basic analysis, like, again, going back to dependency finder, that's looking at the call graph analysis, one hop level, to kind of say, these files are also dependent on this other set of files. And then you have this FE and the FD set. So if there are two people and their FE sets are intersecting, that means there is going to be a merge conflict, right? So there is going to be a direct constraint between these two tasks. If you have an FE set and it might have some impact on this FD set, which somebody else might be working on, right? So then there will be an impact. So we call this the indirect constraints. So right now we are only looking at FE sets, impact on FD set, which is being changed by someone else. It could be that there are two different sets and the impact is somewhere downstream in another set of files, and that needs a little more refined analysis. So once we have these constraints, we need to evaluate them, and we're using Microsoft Z3. So we have these constraints between all these tasks. We put it into Microsoft Z3, and if there's a solution, that is, there exists for these two people two tasks that do not constrain each other, right? Then what we want to do, there is a solution, but we want to try to match it as close as to the developer's preference or the developer's priority. So to do that, we look at, OK, this is a solution that Z3 gave to us. 4, 2, 3, 1 is an order, which won't have any problem. But the developer wanted to do 1, 2, 3, 4. So it's kind of very far from their preferences. So what we want to do is minimize the cost. So if it is, we find out how far. So 4 was 3 hops away. So we say, OK, there are 3 units is the cost at this point. So we try to say, OK, for this solution, how far is it from the developer's preference? And we make a cost object out of that. And then we put that cost back as a constraint and say, in this case, there is 3, 2. So there's at least 5 places that would be changed, right? So we want to say, we want to put that back in the constraint solver and say, try to minimize this cost from, say, 5 to 3. So we kind of go binary and see if there's any solution. So we go back and try to reevaluate the constraint space. And we keep doing that until we find the cheapest cost function that we have, because that's the minimal set we could get. And then we want to display this information back to the user as said, this is your recommended task. To do that, the UI what we have is, this is Mylin, and over here is the Mylin's task view. We kind of hijack that task view, task list, and say, OK, if these were the tasks that existed for this particular person, and 1, 2, 3 was the ordering that they were going to do. Mylin does not allow for task reordering, so we had to put a plugin that allowed that. So the developer can say, implement plot should be actually number 1 and not number 3, so they can move this. And there is this little tick mark that says, OK, run the constraint solver now. So we run the constraint solver 2 times when the user says, run it now. And the other part is when someone has checked in their code, what we say, like the other people who are still working on, I finished my part, what is the next task I should do? And it takes some time for people to check in their code, write the comments and stuff like that. So we use that time to reanalyze the constraint space and saying, some constraints will be added, some will be removed based on what other people are doing, what files you have changed, and say, this is the next best task for you. So when we give this visualization of what's the next best task for you, we kind of say, this is the order which we want you to do. And there's a little exclamation mark that says why we want you to look at that. And over here says, this is your task ID. It conflicts with this other person. What is the task that is conflicting? It is direct or indirect conflict that could be causing this. So the idea is to kind of say, like, it's not just like, hey, you have to do task number 2, but saying if you do task number 2, these are some of the problems you will face. And seeing if developers actually reschedule or do the same task, or they actually pick Cassandra's order. What happens if there is no solution, right? So this was the first case when we ran the constraint space, we found 2 tasks that were independent of each other. What if there's no solution? What if it's an unsat situation? Then what that means is we have to relax some of the constraints. We cannot relax any of the hard constraints because something has to be done before this other can be done, right? The output is needed as the input for this task too. So we can relax some of these softer constraints. And the way we relax soft constraint could be very much dependent on the team policies. So you could have, for example, a conflict focus. Initially, when we started this, we assumed merge conflicts are easier to solve. So we could just say, if there is no solution, just break all constraints that cause direct conflicts, right? But after looking at the data we had, the Perl data, in Perl, builds is easier to solve than merges are, right? So again, it might depend on the project's profile, what tasks and what conflicts you want or you do not want. It could be team focus. For example, as I said, it might be OK for 2 people to have a problem as long as the majority of the team doesn't have any conflicts. It could be task focus. We could say these 3 tasks are going into the release now, so nothing should ever impact these tasks. Or it could be these files are frozen because we are ready for release, or these are a public API, so all constraints relating to this particular file should be left alone. We started with looking at conflict focus. That was the easiest to do. So what we do is when we have an unsat model, a basic model was start relaxing by you can do all direct conflicts or you can do one conflict at a time. Z3 right now does not give a minimal set. It says, OK, these are all the constraints that could happen. But it could be that if you relax one of the constraint, the solution would still work, right? So there is some optimization that we can do. Right now for starting, we said, OK, first step, let's relax all the direct conflicts and see how fast and how much time it takes. The other one is empirically guided. So you can look at your particular project's profile and see builds are easy. So I'm OK with removing indirect conflicts maybe. But in this case, you have to be a little more fine-tuned and say remove one conflict at a time, run the constraint solver and see if you get a solution, and then keep doing that. So there are some of the underlying assumptions here. We are assuming developers select a task from a given set. So there is a set that is awaiting for them at the beginning of the day or a week or a month. There is a task context that we know for this task, these kind of resources are going to be changed. We know that ahead of time. We're doing very coarse-grained analysis right now. That task assignments are done at the beginning of the period. So the weekly time, I know these are my tasks for this week or a particular sprint. There's one active task per developer. It's not that a user has 3 or 4 or 5 tasks all opened, because as soon as you're working on a task, we concretize those constraints. So we say this person is working on this, nobody can touch these constraints, right? We're also assuming tasks are unique across developers and non-transferable. It's not that I start something without checking it in, I email it to someone else, so there are 2 tasks going on at the same time. Another thing is we're assuming developers commit their changes at task completion. And this is kind of important for the approach is initially when we are starting, there's going to be a lot of noise in the data because we are kind of looking back in time to find which files will be changed. We're looking at just call graph analysis, so there's going to be over-approximation in the dependencies we have. But we're assuming as developers are making changes, we have much more fine-tuned, fine-grained idea of what's changing in the dependencies. So when I have completed my first task, then I have the tool has a much better idea of the constraints that's out there to get a much better prediction for the next task you're looking at. But if you don't commit your changes, then it's going to be a lot of changes or a lot of constraints in the space leading to unsat solutions. I'm not going to go into depth with this because I'm sort of running out of time. So to evaluate it, just to see if Z3 and constraint solving would work in an open source setting, we looked at the 4 projects we had, Jenkins, Perl, Voldemort, Storm. We looked at weekly data, monthly, quarter, and 6 months data. And I want you to focus on that in many cases, we had the direct and indirect conflicts, so 12, 34, 49. We ran it. We saw SAT conditions as well as unsat conditions. When we had the unsat conditions, we relaxed some of the constraints. And if you look at it, we got the solutions. There was number of conflicts that got avoided, 4 out of 5, 33 out of 35, 36 out of 40. So we're pretty good in resolving these problems. Of course, in this case, we knew exactly what the change sets were and what the dependencies were. Right? So there was no false positives involved because this was gotten data after the fact. OK, conflicts avoided. Another thing is time was pretty, this is in seconds, so it was pretty fast. When we looked at it, it was 63% developer preferences matched, 23-25. So we ran it again to see as close as we got the developer's preference. And in this case, developer's preference was just based on the order in which the changes were done. And we saw that most times we got pretty close to developer preferences matched. Only in one case it timed out, which was set for 3 minutes. So the solution works pretty fast. So to summarize and to conclude, what we have is what I have showed you now is there are dependencies. it's hard to understand what these dependencies are. So here is a set of tools that actually let you explore these dependencies through Tesseract, which looks at different project elements, aggregates these different types of relationships as networks that exist. They're cross-linking, and you can look at it over time. The other set of work that I talked about is how can we schedule, or how can we coordinate the tasks or different changes that developers are making in a team context. And one thing is, we want to eliminate seclusion. So if you're in a branch, if you're in a private workspace, it's not that you do not know what's happening around you, but we are insulating it. So you have some information. Going from early detection of conflicts to scheduling tasks to avoid the conflicts altogether. And another thing we have not talked about is a lot of the stuff that I spoke today was very coarse analysis at the call graph level. But can we use the development context to do much more finer grained analysis, but scope it, say, for the behavioral changes? For example, if you want to do semantic analysis like symbolic execution, doing for the entire code bits is very expensive. Can we use the development context like code ownership or who's active now to scope this analysis space? Thank you. Work is supported by a bunch of NSF grants and an Air Force grant. I thank my students in the lab, Josh, Corey, Bakhtiar, Sandeep, and Raphael, who did a lot of the work, most of the work, which was after I graduated. Thank you. Questions?
Any time for questions?
So in practice with that, how are people willing to put in that upfront work to save like later costs?
That's something I need to look at as a user study. So one of the things I think to help them understand, and that's why we did the past study to say like how much time it takes for resolution. The resolution time is less. They would not put that upfront time, right? This was a study done by Mylan, so they were eating their own dog food, and there they found that because what Mylan would allow is putting the degree of knowledge information or degree of interest information that tells you which other files might be changed. People wanted that information badly enough that they actually put that extra time to say, I will be changing this, and this files. So in Mylan, it worked, but it was a research group. So this remains to be seen how it's going to work. Going back to the Palantir study, which was less upfront work, but the first time when they saw the conflict, they wanted to just race ahead and finish it. But the next time they found the problem, before they wanted to go ahead and finish their task, they always started the communication and say, I'm going to change these things. What are you changing? So people seem to be very conflict averse in the settings that I had seen. So if this will help resolve or help you not even have those conflicts, I believe they should be. But it depends how the development context and team policies are. The cultural thing. Yeah.
More questions? I can ask one. So, in a way, the conflict avoidance is kind of like pessimistic concurrency in version control, where if somebody has that file out and it's locked, you can't check it out, you can't touch it. Which brought to mind the idea of offline work. So one of the challenges, if you're not connected to your source control system and something's locked, you can't check anything out, you can't do any work until you connect. So this eliminates essentially parallel development, or the ability for parallel development, if you're avoiding these conflicts. And that was just sort of an observation. But a question I had around this was, in the studies you did of those open source projects, the 4 that you put up there, how big were the conflicts? Were they multi-person? Were they more than 2 people usually? Or like if you needed to coordinate work to avoid a conflict, was that just coordinating between 2 people's tasks, or was it like 15 people needed to have all their work coordinated?
These are open source, so they were smaller. And the way we defined the conflict was when 2 branches were merged. So by definition of a problem, in this case, was 2 people, because there were 2 branches that were merged. So it's always 2 people. But we are looking at kind of branch study, and at some point in Voldemort, we had 15 branches that were active. And I think there were 5 or 6 unique developers. So because it's Git, everybody has multiple branches that's going on. So I think the worst case we have seen is in these projects, 6 people working simultaneously. but the problems that I have shown is by definition 2 people. So if you broaden it out and we look at this point, if all the branches were to come in, there would have been 5 people you have to coordinate. Does that answer your question?
It does. It has a follow-up, but I'll let Chris.
It's kind of a separate.
I'll let you ask your question.
Yeah, the follow-up is, so you put in a lot of work into the stat system to try to automatically schedule things. If it's potentially just 2 people, or let's say it's a small number of people, could you get away with just a visualization of, here are the, like a Palantir-like visualization of, here are the tasks that might overlap with this person or that person, and if it's not too complex to see, maybe the people can just figure it out for themselves which ones to choose.
That's possible. So if it is, so we were going for the hardcore case where you have 15, 20 people working together, but if it is smaller graph of people and relationships, we could just leave it as a visualization and let them choose. The only problem would be it might become combinatorial depending on how many tasks each person has. Sure. So that's where having some automated tool would help. So Z3 was pretty easy. We locked it, plugged it in, and it does magic behind the screen. So
You've been looking at this kind of awareness and kind of conflicts, though you may not have called it like back in Palantir or whatever. What is your feeling about like the type of granularity that people should be looking at when you talk about conflicts? So in one of your tools, you're looking at changes to individual signatures on methods. I've seen things to files or components. What are your thoughts on how one should think about, or what level of granularity we should look for these things?
It's a difficult question. It's a good question, right? So the granularity of the changes has 2 issues. One is the human level scalability of understanding, I am working on this particular file, I know it's going to affect this other file. It's much easier to do than looking at another team, another component. But if you are having a higher granularity of changes, doing any kind of impact analysis gets more complicated with a lot more possibility of false positives. Right? So if you're looking at the component change, you have a lot of changes, and it could be this, all these changes have a lot of effects, and if you're over approximating, you'll have everything as being affected.
You get into deadlock for no real reason. Right?
Yes, you can have deadlocks, because even if we are looking at this, even if you look at control flow graphs, right? Most of them get over approximated. If you want to be sound, that is, you want to catch all the problems, then it gets over approximated and everything gets affected, so you have one big lump. If you are being too tiny, then you have an easier, so the smaller the change sets, the easier it is to understand. So one way of thinking of this, I would say, depending on the user's needs, so we are talking, it's completely client needs, right? So if as a manager, I want to say, tell me all the components that are a problem, but I think underlying that, we should have for each of these components, these files, these methods, this line was changed, and from there do the impact analysis and aggregate the results back to a form that users would like to see. So for the technical part, the smaller the change, the better it is, the lower granularity. For the people part, you need some kind of aggregating and moving things up. Because otherwise it might be just too many information that would be difficult. And that's one of the reasons I'm moving away from the Palantir stuff, which was all file-based, and we're trying to get to a more higher level task-based understanding.
To address Gina's question about requiring people to put in a lot of metadata about what each task might touch, could you use some sort of requirements traceability analysis to take a task and automatically figure out what files or functions it's going to be touching, and at least as a first approximation?
Yes, you could. I was not going to requirements traceability. I was looking more data mining part, but that would only work for past bugs. So if there was a bug request, then we would like to find similar past bugs and then do a seed of these were the files that changed for a very similar bug, and then the user can refine that. But if it's a new feature, then we could do some kind of requirements traceability part to say these are the possible files you might want to do. And then they can refine it. So that's the goal. I think starting with a blank slate, nobody would do that. But as I think we were having a discussion, if there's a false positive that you say for this task, these 5 files need to be changed, I think a user will be more apt to say, no, not this file, but this file. So correcting something might be easier for the user than working from scratch. So that's something definitely you want to look at.
More questions? All right, well, let's thank Anita for her talk.
Thank you.
here at Self Friday.